Now, next topic, that is potentiometer. Potentiometer, that is the circuit with the help of which one can find the EMF of the cell as well as internal resistance of the cell, and one can compare the EMFs of cells. Okay, as well as potentiometer circuit can be used as potential divider circuit also. Now see the figure. Here, this red circuit given to you, that is the potentiometer circuit. In potentiometer circuit, between A and C, the long wire is connected. This long wire, that is of the length 200, 300, 400, 500, 600 centimeter. Okay, as per convenience. Okay, it is mounted on the plank. Then between A and C, here a battery with internal resistance R and a resistance box, or we can say the rheostat, is connected to control the current in the circuit. So this particular circuit, that is known as potentiometer circuit. Clear up to this one? Now here, first of all, we have to calculate the potential gradient for the potentiometer wire. Potential gradient means what? Potential gradient, that is nothing but the potential difference per unit length of the wire. But to find out the potential difference per unit length of the wire, first of all, we have to calculate the current constituted in the circuit. Now see here, to operate the circuit, the battery with EMF E and internal resistance R is connected. The resistance box R, that is connected in series with it, and a potentiometer wire. All these are connected in series. So we can write the current constituted I, that is equal to E upon R plus resistance of potentiometer wire, that is resistance of AC wire, plus internal resistance of the battery. Now, suppose this current is constituted now. So if current I is flowing through this wire AC, then potential difference between two end terminals A and C of the wire, that we can write. So potential difference across AC, that is current I into resistance of AC. Now substitute the value of current I here. I, that is E upon R plus RAC plus small r into resistance of AC wire. Now here, suppose the resistance per unit length of the wire, that is sigma, then total resistance of this wire, that we can write RAC equal to sigma into LAC, where LAC, that is the total length of the wire. Now this is the potential difference across entire wire. So if we take length of the wire on left hand side, so potential difference across AC divided by length of AC wire, then we can say this left hand side, that is nothing but the potential difference per unit length of the wire, and that is called potential gradient. So we can write that is E sigma upon R plus length of AC wire into sigma plus R, and this is denoted by phi. This is called the potential difference per unit length of the wire, that is potential gradient. Clear to all of you? Now see, when between these two terminal A and C of the wire, total potential difference, that is VAC. So in other words, we can say this wire itself will behave as a source having potential difference VAC between these two terminals. So here, suppose we take one wire from terminal A, which behave as positive terminal because it is connected with positive terminal of the battery. And then after, suppose we take another wire from any point of this potentiometer wire. Now, if here the length of the potentiometer wire used, that is the small L, then across that particular length of the wire, the potential difference obtained, that is 5 into L. So in this way, suppose we fix one terminal of the wire here at A and we keep another terminal as variable, and these two terminals are connected with voltmeter, then for that variable terminal, as you change the position of that terminal on the wire, then different length of the wire will appear in the circuit, and now you will get different potential differences. So we can say potentiometer circuit can be used as potential divider circuit. એટલે કે તમારે અલગ 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 પોટેન્શિયલ્સ જોઈતા હોય તો તમે આ સર્કિટનો યુઝ કરી શકો. Clear to all of you? Now using this potentiometer circuit, we can find the EMF of the cell. See, in normal condition, when you use the voltmeter to find out the voltage between two terminals of the cell, then what happens? Suppose we connect the two terminal of the cell with voltmeter, then the closed loop will be formed. Cell, voltmeter to cell, loop will be formed. So current will be constituted. So current will flow through the cell. If current flows through the cell, then the potential difference between two terminal of the cell, that is not EMF of the cell, but that is the terminal voltage of the cell. Now, if you want to find the EMF of the cell, then you have to make an arrangement in which the current flowing through the cell, that becomes zero. So if current flowing through the cell becomes zero, then whatever is the potential difference obtained across two terminal of the cell itself is the EMF of the cell. Now to find out the EMF of the cell or comparison of EMFs of the cell, we have to connect those cells as shown in the figure. Suppose two cells having EMFs E1 and E2 are connected with a potentiometer circuit as shown in the figure. Positive terminals will be connected with positive terminal of the potentiometer, means terminal A, which is connected with the supply battery, or we can say driver battery, which one is operating the circuit. Then negative terminals are connected with two-way key to terminal 1 and 2. And with this terminal number 3, a galvanometer, and then with galvanometer, a jockey key is connected, which is the variable terminal. So in this way, first of all, we have to prepare the circuit. Clear to all of you? Say, this one is the jockey key, right? Now, here you have to connect the wire to this particular terminal and other end of the wire, that is with galvanometer here. Now, this part of the jockey key that you have to move on the wire, okay, to obtain the null point. Clear to all of you? Now, suppose in this circuit, first we connect terminal number 1 and terminal number 3. So here the cell with EMF E1 that is now connected in the circuit, the cell with E2 EMF that is at present disconnected one. Now, with the help of jockey key, you have to find the null position on the potentiometer wire. So here what happens, see, suppose jockey key is placed at point N1. So length of the potentiometer wire from A to N1, that is suppose L1. Now we already discussed the potential gradient. Potential gradient, that is the potential difference per unit length of the wire. So here L1 length of the potentiometer wire give you the null point. It implies that between these two terminal A and N1, the potential difference that is L1 into phi, that is L1 into phi. And this L1 into phi potential difference that is exactly equal to the potential difference between two terminal of the cell. And when you are getting null point means through the galvanometer, when the current is not flowing means through cell, the current is not flowing. So whatever the potential difference is obtained here between two terminal A and N1, which is L1 into 5, that is exactly equal to EMF of the cell. So we can write here potential difference across A and 1, that is equal to E1, that is equal to L1 into 5. Now disconnect these two terminal 1 and 3 and connect the terminals 2 and 3. So now this second cell with EMF E2 is in the circuit. So for that, again find out the null point. Suppose the null point is obtained at N2 and length of the potentiometer wire which give you the second null point, that is L2. So we can write the potential difference across A and 2, that is equal to E2, that is L2 5. So now take the ratio of these two equations. So we will get E1 upon E2, that is equal to L1 upon L2. Now, if we have the value of potential gradient, then you can calculate the EMF of the cell, and in this way you can compare the EMFs of the cells. Clear to all? Now using potentiometer circuit, one can find the internal resistance of the cell. Now see, to find out the internal resistance of the cell, we have to prepare the circuit as shown in the figure. See, A to C, that is potentiometer wire, then rheostat, this is the driving battery, which one is operating the circuit, then the cell for which you want to find the internal resistance. Its positive terminal that we have to connect with. Positive terminal of the potentiometer means with terminal A, which is connected with the battery, B, and of its positive terminal. Now internal resistance of the cell, that is a small r, which is shown in the figure here. Then other terminal, that is with galvanometer to jockey key. Now this particular cell for which you want to find the internal resistance, it is shunted by resistance R. Shunted by resistance R, it implies that parallel to this cell, you have to connect one resistance R as shown in the figure. And with that, one key is also connected. Now, first you have to keep this key open. When the key is open, we can say R is not in the circuit. It is open circuited. And now find out the null point. So here, suppose the null point is obtained at position N1 and the length of the potentiometer wire appears to obtain this null point, that is L1. Then we can write the EMF E, that is equal to L1 5. That is the potential difference or potential drop across A and 1. Then after, press this key. Means we can say now the key is closed. So this resistance R is now connected parallel to this cell. So see here, a loop is formed. So in this particular loop, suppose the current I is constituted. So potential difference across this resistance, that is IR, the same will be across two terminal of the cell because this is the parallel combination. And now for this connection, suppose the null point on the potentiometer is obtained at position N2. And the length of the potentiometer wire appears to obtain this null point, that is L2. So we can write the terminal voltage of the cell, that is L2 into 5, because now current is flowing through the cell. So whatever is the potential difference between two terminal of the cell, that is the terminal voltage. So we can write V, that is L2 5. But here we can write V, that is equal to IR also. Now suppose here we take ratio E to V, then simply you can write E by V, that is L1 upon L2. Now what is this current? So that is I equal to E upon R plus R. So we can write E, that is equal to I into R plus R, and terminal voltage V, that is equal to IR, that is the potential difference across resistance also. Now if we substitute these two values of E and V in this particular equation, then E by V, that is I into R plus R upon IR. So I cancel, that is equal to R plus R upon R, and we can write this R plus R upon R, that is equal to L1 upon L2. Now R by R, that is 1. Small r upon capital R, that is L1 upon L2. Take this 1 on right hand side. So small r upon capital R, that is equal to L1 by L2 minus 1. Then take this capital R on right hand side. So we will get small r, that is equal to capital R into L1 upon L2 minus 1. So in this way one can find the internal resistance of the cell also. Clear? Example 3.10. A resistance of R ohm draws current from a potentiometer. The potentiometer has a total resistance R0 ohm as shown in the figure. A voltage V is supplied to a potentiometer. Derive an expression for the voltage across R when the sliding contact is in the middle of the potentiometer. See, total resistance of the potentiometer wire that is given to you R0. And this sliding contact that is exactly at the middle of the potentiometer wire. Okay. Now see, if the sliding point is exactly at the middle point of the potentiometer wire, then here, so here on left hand side of this movable terminal or sliding terminal, the resistance of the potentiometer wire that is R0 by 2, and on right hand side of it, the resistance of the potentiometer wire that is also R0 by 2. Now see, here this resistance R0 by 2 and this resistance R, both are parallel to each other. Now here we want to find the potential difference across this resistance R. So R0 by 2 and R are parallel. Suppose here the potential difference that is V1. So that is same one for both one. Now if we prepare the equivalent circuit, then we have to find the equivalent resistance of these two. So for parallel combination of these two, suppose we take the equivalent resistance that is R1, then R0 by 2 upon R plus R0 by 2. So we will get here that is equal to RR0 by 2 upon, take here 2 LCM. So 2R plus R0 by 2, 2 cancelled. So resultantly you will get R1 that is equal to RR0 upon 2R plus R0. Now the equivalent circuit will be with resistance R1 as shown in this figure. We supply voltage, resistance R1 means this parallel combination of R0 by 2 and R that is replaced by resistance R1. This R0 by 2 as it is, and the loop is completed. Now, if current constituted here in this circuit that is I, then potential difference between two terminal of this resistance R1 that we can write V1 equal to IR1, and this V1 itself is the potential difference across R also, and that we want to find. Okay, so first of all we have to find the current in the circuit. Now current I, that is supply voltage V upon total resistance of the circuit. So here R1 and R0 by 2, these two are in series. So we can write R1 plus R0 by 2. Again take these two LCM. So we can write 2V upon 2R1 plus R0. Now current I that is equal to 2V upon 2R1. Now substitute the value of R1. So that is RR0 upon 2R plus R0. It is substituted here. So 2R R0 upon 2R plus R0 plus this R0 as it is. Now take this 2R plus R0 LCM. Take it in numerator. So we can write 2V into 2R plus R0 upon 2R R0 plus 2R R0, this one into this, and R0 into R0, that is R0 square. Now this 2R R0 plus 2R R0 will give you I that is equal to 2V upon 2R plus R0 upon 4R R0 plus R0 square. Okay. Now here in denominator, If we take R0 common, then numerator as it is upon 4R plus R0 into R0. Now, voltage V1, that is IR1. So substitute the value of I, this one here, and value of R1, this one to here. So V1 equal to 2V into 2R plus R0 divided by 4R plus R0 into R0. And R1, that is equal to RR0 upon 2R plus R0. So this 2R plus R0, 2R plus R0 cancelled. This R0, R0 cancelled. And resultantly you will get V1 equal to 2VR upon 4R plus R0. Clear to all of you?